Welcome to the Cloud Native Show. So what is Cloud Native? It's APIs, serverless, and containers all managed in immutable infrastructure. I'm gonna go find Brendan Burns and find out what it really means. Hey Brendan.
Hey, how's it going?
Good to see you.
Good to see you.
So what does cloud native really mean? I mean, we're using these terms, serverless, containers, and all these words we're just kind of throwing around, but what does cloud native mean to you?
Yeah, I mean, I think in many respects these words that we're using are, they're just a sort of shorthand that we can use to discuss ideas and concepts that we sort of understand together. And I think your definition may be a little bit different than my definition, but in the general case, it's going to be the same thing. And for me, there's two really important characteristics for cloud native. One is that there's an expectation of API-driven infrastructure. So I'm going to be able to create a machine with an API call. I can create a database with an API call. I can do basically whatever I need to do in a programmatic way. Okay. Not in I put a ticket into a system and somebody got a physical machine and it came and they racked it. Like it's much more like I'm the only one who's really necessary to create something, right? Via an API. And I think the other piece of it is a notion of sort of elasticity and sort of fungibility, meaning like if I need a new VM, I don't worry like, are there parts somewhere? What's Intel or AMD's supply chain looking like? Right. I just say, I need a new machine, and I get a new machine. And vice versa, if I need to dispose something, I just dispose it, right? So I was actually talking to somebody a while ago about this idea of turn space, right? In a data center, if you are gonna, roll out a new infrastructure, you have to think about like how much physical space do I have in that data center to land the new machines alongside the old machines for that 2-day window or 2-hour window when I'm taking down the old service and creating the new service. Okay. In a cloud native world, you don't think about that. You're just like, I'm going to create a new set of VMs. I don't know where they are. They're in the cloud, right?
East, west, doesn't matter.
And I'm not going to have to think about that. I'm going to be able to do these elastic things, right? I think this leads to these patterns. Like blue-green deployments, right? I don't think you could say that blue-green deployment could exist in a non-cloud world because in order to be able to support that, I have 2 copies of my application running at the same time. In a data center, I would need 2 physical sets of servers to run that way, right? Yeah. But in a cloud world, I just create a new set of VMs, they overlap for an hour, I throw them away, I stop paying for them, I'm fine.
Yeah, right? Completely immutable.
So I think blue-green deployments is a great example of a cloud, like one of the very first, I think, cloud native patterns that happened out there. So that's kind of what I think are the essentials. And then, it's grown over time, because we're now starting to think about how does it mean to develop cloud apps and scalability and reliability and all this sort of stuff. So I think cloud native started with those concepts and then grew as more and more people started to sort of enter the discussion and bring their own meanings with it.
So part of the, as the CNCF kind of their definition is, we talk about microservices and containers and I look at microservices and I don't want to slight the term, but is this really SOA redefined?
I think there's a certain amount of that. I mean, I think sometimes we always redefine terms to I think there's differences. Okay. I think that there's more of a focus on not just the services, but actually how you package and deploy the services and horizontal scalability, right? Okay. So like in an SOA architecture, I don't think that, a monolith versus micro, I don't think that entered into the discussion. Yeah. I think it was really just about like, hey, let's define formal APIs for web-based services. Right. Right, that was the first, so SOA influences. I think microservices is actually talking also about how the systems are actually implemented, not just the APIs, right? And I also think though that like microservices and again, it's one of these terms that like the meaning is very broad and mixed depending on who you are, but I think people are also starting to say things about like how you actually develop things, meaning the 6 to 8 person team size is really an ideal size. So microservices isn't just saying, hey, you should expose some APIs.
Yeah.
It's actually also saying, hey, if you want to be agile and be able to successfully deploy your software, your service scope should be right in the 6 to 8 person team size, because that's the optimum in terms of development velocity.
Okay.
So you design your services not just for the APIs, but actually for the execution of the teams as well.
I mean, are we going to get to the point where we start calling things nano services and start getting, something silly like that?
I actually think it's far more likely we're going to go back in the other direction.
Okay.
Right, and people are going to say, oh my God, I got this, soup of, I've got 10 engineers and I've got 30 services. Like that's going to be the new monolith. The new monolith, the monolith is sort of a dirty word now, and I think the next version of this will be when people are like, oh my God, we have to consolidated services, or I don't know what the term will be, but I think if there's going to be a reaction, I suspect it's going to be more of a contraction than an expansion.
Well, I think in this industry, I know we both have kind of been in the industry for a long time. We've seen these, we put everything on the server, we put everything on the client, then we break everything apart, we put it back together. I know this pattern, if you will, of distributed applications and a ton of little parts, and we've got our configuration in 12 different repos, and I've got 7 clusters for every environment. What is the hardest part of where we're at right now? Is it tooling? Is it, everything's on the command line for me right now. I'm typing, kubectl, blah, blah, blah.
Yeah.
Is tooling the challenge?
I think tooling's an important challenge, a really important challenge, and I think sometimes one of the challenges that we run into in the industry is that the people who are really excited about the technology parts of it are not necessarily excited about the tooling.
Yeah.
Right? And so finding those people who deeply understand the tech, but also want to take the tech and make it easy to use, that's an important challenge, and I think actually one of the great strengths that we have here at Microsoft. Right. I also think that one of the challenges is, I guess it's tooling in a way, but it's around observability and debuggability, right? Like we're decoupling everything for team velocity, but because of that, we're losing the all-up perfect visibility. Right, and so we also have to build the kinds of things that help us better understand what we're building and how to build it. It's still just too hard. Right. It takes too long. Like it's not that they can't do it. It's just that I think we're still in sort of this assembly language phase where you're typing out all these little instructions, and there's no way that all of the stuff that we do today could exist if we were still programming in assembly language. It would just take too long. Yeah. Even if we were smart enough, it would take too long.
Well, I get into situations where, okay, I know what it takes to build a cluster. I know what it takes to build a microservice. I know what it takes to deploy all these things, and I'm doing it. If I was a one-man shop, if I was a startup, I find this to be just completely overwhelming. And then, when I think the biggest struggle for us, even as engineers, when something goes wrong, I heard an analogy that you had mentioned to one of our colleagues of, when do I reach for a book? Yeah. And I think that for me, that's when I reach for a book is, oh, great. And then I might get some feedback where it's like, oh, you have to SSH into the node of your cluster to restart the VM. And I think we should be at a point where I don't have to think about that.
Yeah. And I think we're really pushing. I'm trying to push very hard, and I think Azure as a whole is trying to push hard into that, into that world. I view it sort of like, what happens below the instruction set in the processor. I have a friend from college who's worked on, processor microcode for 20 years, right? And the amount of stuff that happens below that machine instruction is actually amazing, right? But we never think about it.
Sure.
Every once in a while we think about it when there's a bug, but it's very rare, right? And so I think, the complexity is always going to be there. The key is defining those abstraction layers so that you can mostly ignore it. And we're not quite there with cloud, right? Like we haven't fully hidden the VM. I don't think the VMs are ever going to go away,
right?
But we have to get to a place where they're really, really fully hidden for, say 99.99% of the population. Right now, we're at a world where maybe that's 50% of the population, and I think we have to keep pushing towards that. I think we are pushing towards that with serverless containers and things like that, functions as a service. But we're not done, right? Because the places where we've done it are too narrow, too vertically defined. And so people keep having to go to raw infrastructure because they need, some library, or they need some, native code, or whatever it is that the platform doesn't support. They go to a VM, and now they're in that world where they have to SSH.
Do you think that they jump down to that VM because it's still what I know? They go, well, I want to work on the serverless. I think that's what I should be doing because that's what the industry is telling me. But, we have both, I'm sure, talked to many enterprises where they're like, wait a minute, I've got 12 VMs that are still sitting in my server closet. That's what I know. That's what I'm comfortable with. How do I get to this, next thing?
I'm actually I encounter that less. I think it's more people have had their fingers burned too many times.
Right, okay.
Right, they've gotten 6 months into this new platform and they've loved it.
Yeah.
And then there was some NPM package that they wanted to pull in. And that NPM package used some piece of native C code, and that didn't work on the functions as a service because of the sandbox that they were using.
Okay.
Right? And so I think you do that 2 or 3 times and you just get your fingers burned and you're like, I'm not even gonna bother with those platforms.
Right.
I'm gonna go with the VM. Yeah, I know it'll be hard, but I know that I'm not gonna get stuck. Right? So I think that the concern about people getting stuck is bigger than this is what I know.
Right.
I do think it's really important. I mean, I also think though that if you want to introduce new ideas and new tech, you can't make someone feel less powerful than they are currently, right? And so if you say hey, yeah, great, learn this thing, it's gonna take you 6 months to get back to where you are right now with VMs, never gonna work, right?
Sure.
That person's gonna stick with VMs for the rest of their lives. It's an important aspect. I think we do a pretty good job with that in many cases. Containers did a good job with that, but it's an important consideration.
I think we're getting to a stability factor right now with containers. I think, if I go back, I don't know, maybe 2-3 years ago, that containers was that still felt new. It was, are we doing, Swarm or Mesos or Kubernetes? What was the thing? I think we have some clear winners there.
Yeah.
I think the tooling is getting better. A lot of the IDE companies have really good tooling and stories there. Debugging is certainly better.
Yeah.
So I think that's kind of leveling off. But now it's what's the next level of uncomfortableness for us as developer engineers? That's where we're having to get to next. Is where we're at now with Kubernetes and what we're doing here, at Microsoft is that our end game, or are we marching somewhere else?
Well, I think it's 2 pieces. I think when you talk about tooling requires sort of consolidation. So when there's 4 different orchestrator APIs, it's really hard for you to have great tooling.
Yeah.
Because the tools people don't know what to target, right? And I think there's still places, Service Mesh is a great example. So one of the reasons why Microsoft and a bunch of partners came out with the Service Mesh interface is because, it's very hard for the tools people to build tools for Service Meshes if there's 3 or 4 different implementations, right? And so I think at all of these layers, orchestrator, now we have some consolidation.
Yeah.
But the next layers up, debugging, monitoring, we're starting to see some consolidation, at least around the Prometheus interface for scraping. So we can start, and Service Mesh, hopefully we'll see some consolidation. That enables better tooling. That enables most people to just kind of use it and not be thinking about what's the implementation.
Sure.
Similarly with serverless, I think what we're really trying to do is say, hey, yeah, great, we've identified that container. Let's see if we can't make container the process for the cloud, right? Let's get rid of the VM. Let's just say, hey, if you give me a container, you give me its requirements, we'll run it for you, and you won't have to worry about where it runs. And that's the abstraction layer. The container becomes the abstraction layer for literally how you package your executable. I'm hopeful that we'll get there. We're not there yet, but I'm hopeful. And in all these things, it's in partnership, right? Because we can't just dictate, right?
Yeah.
It has to be something that the entire, or at least the majority of the world decides to go and do, because companies are going to run in multiple clouds, companies are going to run in their data center.
Sure.
We've got to embrace that hybrid world.
The containers is becoming almost a de facto standard of how we at least package and deploy our apps, at least the small apps.
Yeah.
And small is, I don't know, an opinion. I think what small is. Obviously we've got the Windows. Windows is getting into that range. But also when we talk about distributed apps, and I think when I think about cloud native, and my definition is, it's really just distributed apps.
Yeah.
Because we can't just think about the cloud, because now I can run a container on a drone. I can run it on, a Raspberry Pi, and that's really a distributed app. So I'll ask you, I know cloud is not the end game, but is there another place that you think will end up other than cloud? I think IoT might be that next place.
Yeah, I mean, I think this is one of these reasons why something like containers, it's a very broad term, right? Because there's the packaging parts of it, and there's the deployment parts of it, and there's the orchestration parts of it. I'm not sure we're ever going to run Kubernetes on a drone.
Right. Don't challenge anybody.
No, I know, seriously, right? I was just actually talking to some people who are talking about putting it in cars. So, I should never say never, right?
Sure.
But we are going to talk about how do I make some of the ideas around staged deployment. Maybe not to one drone, maybe I have a fleet of drones.
Sure.
The idea of a rolling deployment, of a canary deployment, those concepts that are in Kubernetes make a ton of sense across that drone fleet. And I probably don't want to rebuild it. So when the stuff we're seeing IoT do with Kubernetes for deployment shows that you can take some of the ideas that are in these orchestrators that were built for distributed systems and actually take them to, it is distributed, but it's a different kind of distributed system if you're rolling out software across a fleet of drones. So I do think that's true. I do think that one of the other themes that I see a lot is, and this is sort of microservice-y, is we built these things, Kubernetes or ARM or many of these systems for one purpose. Now we're starting to see people say, hey, could you break that piece out?
Yeah.
I just want to have access to RBAC. I just want to have access to the extensibility of the Kubernetes API server.
Right.
I have some new API objects. I don't even care about Kubernetes maybe, but I want to create an API. This seems like a really easy way for me to create an API. Can I just use that part, right?
Yeah.
That's been really interesting to see as well.
Awesome. So. If somebody wanted to get started, they're not understanding where this, where we're at right now, what's the advice that you would give to a startup or somebody that was maybe a fresh engineer coming in? Where would you lead them?
Well, I mean, the first thing I always talk to everybody about is like, what is your pain at some level, right? Like, what is the thing that is holding you back? Because we shouldn't just adopt tech because we're talking about it or because it's because it's there, or it's in some magazine or some website or whatever. Right. You should adopt tech because you believe that it's going to make your startup move faster, or it's going to make your customers happier because your product's more reliable, your engineers happier, your on-call happier because it automatically restarts stuff, right? So I think that if you have a clear understanding of what's your current pain, then you can take a look at a technology like containers and say, hey, we have a real pain point with our developers. None of the code works on everybody's laptop, because everybody installs different libraries and and they same sort of run it on my laptop, run it in the cloud is the same. It doesn't work, right? Containers will help with that.
Sure.
There's a great example of some pain that they can help with before you even get into deployment, before you even get into orchestration. But you could also say, hey, we don't know how to reliably roll out software, right? And we don't even trust our developers to reliably roll out software. We want to use a fully integrated CI/CD system. We want them to push into Git, a whole bunch of tests are run, deployment happens via automation. Now Kubernetes is a great tool for that, as well as the CI/CD pipeline, right? So I think identifying your pain first and then figuring out which of the collection of technologies helps address that pain is the best way to do it. And obviously Azure has a great set of technologies, from containers, the container registry, to the container service, to container instances, to Azure DevOps that can really help address any of those pain points.
Awesome. Well, I appreciate you taking the time.
Oh yeah,
and,
no worries.
Letting us know what you think cloud native is.
Yes.
And where
everybody should form their own opinion, though.
Form their own opinion. So that was What is Cloud Native on the Cloud Native Show with Brendan Burns. Be sure to check out aka.ms/Cloud Native Show for future episodes, and thank you for joining us. Thanks for watching the Cloud Native Show. Be sure to subscribe, watch for future episode, and especially our streaming shows on Twitch, where we build apps based on the conversations had right here. We'll see you next time.